The topic of this section is about application layer. We will briefly introduce application layer, and then we'll explain an application called DNS. Amongst all the layers in the reference module, application layer is the nearest one to user. It provides application program with the network communication. The diagram lists many types of application layer programs or protocols. This program or protocols can be used by other programs. For example, the web browsers can use HTTP directly to enable network communication. Application layer is quite important. No application layer, no network communication support. It is the only layer does not provide service to its upper layer, as it provides service to applications which are outside of reference module. Application program can be divided into direct and indirect. Direct, such as browser, email, FTP, telnet. This application directly use application layer service. Indirect, such as Word, Resource Manager. This application indirectly use application service. We are going to introduce one of the famous applications, Domain Name System, DNS. Using IP addresses as absolute machine addresses on the internet is not very practical. Two reasons for it. Reason one, computer can be frequently change IPs, rendering using an IP address to access the machine useless. A system of using a name to access the machine was devised to overcome this problem. Reason two, it is not easy to remember IP. In the ARPANET, there was simply a file, hosts, that lists all the hosts and their IP addresses. This scheme works well when network is small. DNS is a hierarchical domain-based naming scheme and a distributed database system for implementing this naming scheme. DNS works in this way. What DNS really does is to map name onto an IP address. An application program calls a library procedure called resolver, passing it the name as a parameter. That is, getHost by name is an resolver. The resolver sends UDP packet to a local DNS server, which looks up the name and then returns the IP address to the resolver. The resolver returns the IP address to the application, which can establish an TCP connection with the destination or send the UDP packets. Internet is divided into over 200 top-level domains. Each domain is divided into subdomains, which are further partitioned. All domains can be represented by a tree. The leaves of the tree represent domains that have no subdomains but contains machines. A leaf domain may contain a single host or represents a company that contains thousands of hosts. Top-level domains can be generic and country domains. This diagram displays example of some domain space. On the left, it lists some generic domain names. On the right, some country domains are listed. Both sides demonstrate the feature of hierarchy we explained previously. Each domain is named by the path upward from it to the unnamed root. The components are separated by periods, pronounced as dot. the domain name can be either absolute, ends with a period, that is eng.sun.com, or relative, it does not end with a dot. Relative ones have to be interpreted in a context to find the true meaning. Both of them, relative or absolute ones, refer to a specific node in the tree and all the nodes under it. Domain names are case insensitive, and the component names can be up to 63 characters, and full names should not exceed 255 characters. A resource record has 5 parts: domain name, time to life, class, type, and the value. Every domain, either single host or a top-level domain, should have a set of resource records. When a resolver gives a domain name to DNS, what it gets back are the resource records associated with that name. Thus, the primary function of DNS is to map domain names onto resource record. So that's it for this section about application layers. Thank you very much.